Hey everyone. Hey everyone. First of all, very warm good evening and welcome to Developer Donuts, navigating in Kubernetes ecosystem. Before we go any further with today's meetup, um, let me tell you about Devtron sponsors and also the Devtron blogathon contest. So if you are a technical blogger, just passionate about writing, writing about interesting stuff and creating meaningful impact, we have a contest for you, and the end date of the contest is 15th of July. So you can participate and win amazing prizes. You can find the link in the comment section. It has also been pinned in the live chat. And also check out Devtron. All the links will be available in the description as well as this comment section. So do check out their GitHub repo and show some love and give a star. And then without any further delay, let's go ahead with our first session of today's meetup. First speaker of today's meetup is Prakarsh, who is a Kubernetes solution architect at Devtron Labs. Hey Prakash.
Hi Karthik.
Yeah, how are you doing?
Doing good.
Yeah, so
So,
Prakash, could you please tell us about yourself and the topic that you are going to present today?
all right. So, my name is Prakarsh. I work at Devtron as a Kubernetes solutions architect. I have like around 11 years of industry experience. With Devtron, I have been working closely with multiple unicorn startups and consulting them on how to best manage their Kubernetes infrastructure and set up their CI/CD pipelines using Devtron. There are around 4 to 5 unicorn startups that are currently using Devtron for managing their Kubernetes deployments on their production. And it has been very good journey right from when we were like closed source. We were only an enterprise offering, and then we decided to open source the Devtron product because of its utility and open source donuts. So yeah, that's pretty much about me.
Awesome. So, could you please share your screen, Prakash?
Sure, I will be continuing with the session, so I'll be quickly giving you a glimpse of what I will be uh, covering in today's talk. So,
Sure.
the topic for the talk would be, are you helming the right way? So I have seen multiple users across various enterprises struggling with using Helm applications and Helm deployments. So in this session, I will be primarily covering what are those challenges that these enterprises face in their day-to-day life, and then I'll be showing how easily Devtron helps you mitigate those challenges. This is a quick biography about me. So I've already covered that. I work as a solutions architect at Devtron. These are my Twitter, GitHub, and LinkedIn handles. You can go ahead and check that out. I so agenda for today's talk. First, I'll be talking about what is exactly Helm and how does it work. Then various challenges which are faced by Helm users on day-to-day basis. Introduction to Devtron would be there, and there will be some hands-on on Devtron, how it works, how it helps eases your life. That would be covered next, and then I'll be covering some Devtron integrations. We have to come up with several Devtron integrations, so I'll be also talking about that, and then I'll be taking some question and answers from the session or about Kubernetes and Helm, if you feel like. So if time permits. So the It's going to be an interactive session, so I'll be switching between slides and the demonstration tutorial if needed. Uh, uh, okay, so what is exactly Helm? So Helm, as you might already know, it's the most popular package manager for Kubernetes, just like NPM or Homebrew package managers. It's a best distribution channel for your open source softwares. So be it Elasticsearch, if you want to deploy an Elasticsearch cluster on a Kubernetes cluster, you can use the Helm chart for the same. If you want to install a basic software, just like WordPress or even a PHP application, you can use Helm to deploy that on a Kubernetes cluster. So how Helm works is exactly it's Helm is a templating engine. So it has some templates which define your Kubernetes manifest, and then it has some common values that people generally change. So they bring out all these common values in a separate file, which we call values.yaml, and then we apply these values through the templates to generate the Kubernetes manifest. So that is exactly how Helm works. And once these manifests are generated, Helm also applies it to the target Kubernetes cluster. Helm charts are generally stored in Helm chart repositories, which are also called Helm repositories, which are managed by various open source repository managers. So just like, for example, Bitnami has its own chart repositories for storing all their Helm charts. So I'll quickly show you what exactly Helm chart looks like and how it works. So I already have Bitnami WordPress Helm chart opened in front of me. So this is the values file. So this is the Bitnami chart repository that I was talking about, and it has various uh, Helm charts. If you can see all Drupal, Contour, Elasticsearch, everything is there. So I'll just show you. So WordPress is fairly less complex, so I'll just go ahead with WordPress. So if you can see that this is the values.yaml file of the WordPress installation, and if you see, these are the parameters that users might want to change on day-to-day basis. So this is very much elaborate, but you may have fewer parameters. So you may decide to have fewer parameters over here exposed in the values.yaml as per your need. So if I see here, I'll quickly take an example of, like, see, uh, service and then type is load balancer. Okay, so service.type is load balancer over here. I'll quickly show you how this gets rendered inside the service YAML. So this is in the values. I'll quickly go to the templates folder. So this templates folder is where all the templates are stored. I'll go to so in this templates folder, everything is Kubernetes YAML and in a templatized form. So I'll show you how our templatized form looks like. So if I go to service.yaml, which is SVC, and I search for, like, say, type. Okay, this is the one. So if you see here that it's bringing the type value from values file dot service and type. So load balancer is going to be that value, and it's going to paste that value over here and render while rendering, right? So, and a complex example for that would be, you can also apply if conditions and conditions. You can also do that. It says that if the service.cluster IP is defined and the service type is set as cluster IP, you have to do this. Otherwise, not. Right? So you can define such conditions also in the template. So that gives you pretty much flexibility to render the Kubernetes YAMLs and mold it according to your needs. So that's how a Helm chart works. I'll quickly go to next slide. which is the common challenges faced by Helm users. The first and foremost challenge which is faced by any Helm user or any Kubernetes user, I can say, is uh, Kubernetes has a complex access management system. So it's fine as far as you have a fewer number of people in your team, but as your team grows and as the need grows to give access to various people in the organization, it's going to be complex. Uh, Helm or Kubernetes does not provide any sort of uh, uh, access management system which can cater to the needs of all. Uh, Devtron gives you a way to do that, but I'll quickly come to that. So I'll just I'll be covering one by one all the solutions. So let's first discuss all the challenges. So the second challenges is no active monitoring of resources. So Helm just applies the Kubernetes YAMLs and then it does not monitors those YAMLs at all. So if after a deployment somehow a resource like a service or a deployment gets deleted by some user, Helm has absolutely no idea about that this has happened, and it takes no action to mitigate this situation. So that's one shortcoming that I feel about Helm. Uh, and then there is no proper grouping of resources when you're deploying the application with Helm, which means that your Helm chart can have Helm chart can have multiple resources, as many as like some hundreds of resources, and you have absolutely no UI or way to group all those resources and check while debugging. So if a need arise and you want to debug a particular Helm chart, resources created by a particular Helm chart, you just have to struggle finding out what went wrong between these multiple resources. Uh, so that's another shortcoming about Helm. Uh, so and when you're so next is referring to the charts readme again and again is a hassle. So when I talk about that, which means that uh, the Helm readme generally has a lot of uh, values inside them, and just like you saw in the WordPress one itself. So WordPress is fairly less complex than other charts, but it also has so many lines and so many parameters to uh, configure that you can easily get lost between managing these parameters while you are deploying. So that is one issue. So these parameters, what they do are well defined in a read, but you'll have to again refer to that from your terminal if you're using again and again switching context. So you may get lost between those switching. So that is one thing that again I find very challenging when using Helm chart. And then there is a no unified interface for managing or monitoring of Helm applications on your target cluster. So which means that you don't have one place where you can see all your Helm applications and manage your Helm applications from there. Uh, you may have multiple clusters and you may have multiple Helm deployments on those multiple clusters, and having a unified interface would definitely be a big add-on and managing when you as your infrastructure grows. And then there is no out-of-the-box support for temporary hibernation of workload. So once you deploy a Helm chart, you can either remove the Helm chart or you can like let their so if you're doing some sort of POCs and you have deployed a Helm chart which creates workloads that are very memory or CPU intensive, and you want to pause your POCs for some time, you cannot do that. You are left with the only option to remove the Helm chart and then redeploy it again when you need it. So Devtron also provides a very intuitive way to hibernate your workloads. I'll also show you that. Uh, there's no deployment values comparison. So like you see, when you're working with values.yaml, there are hundreds of lines, and there may be many changes which people keep on doing in multiple releases. So Helm does not provide any out of the box way to compare what was the previous version, what were the values which were deployed previously. You might have to use vimdev to go through all those comparisons and get it yourself. So that's again a hassle. Doable, but it's again a hassle. So I'll quickly give you a glimpse of what exactly is Devtron. So Devtron is an open source project which is also backed by an enterprise offering. We have enterprise offering where we manage your Devtron stack on your premise itself. So Devtron does not gives so Devtron always gives a self-hosted solution. It's not a cloud-based solution. So it's not a. It's just that you can install the Devtron stack on your premise on your Kubernetes cluster. We don't have a central Helm central Devtron installation where you can sign up and just go ahead and do your deployment. So because of the security reasons, we do not do that. So it's always better to have the deployment systems hosted at your infrastructure. So that's how Helm is there. Just like you install Jenkins on your infrastructure, you just deploy a Devtron stack on your infrastructure. Helm Devtron is again made for Kubernetes and made on Kubernetes. So Devtron installs on a Kubernetes cluster and helps you manage multiple Kubernetes clusters from one single UI. So you can have one Devtron installation and manage your entire Kubernetes infrastructure on multiple clouds, whether it is GCP, AWS, Alibaba, or any cloud. Devtron also gives you a unified dashboard to manage all your clusters. That's again, and then Devtron also gives you functionalities to deploy, observe, and monitor all your deployments from one neat UI. I'll be covering one by one all the shortcomings in Helm that we just discussed, problems. So access management for team members is the first one. So like I said that Helm does not, Helm or Kubernetes does not gives you out of the box access management. So I'll quickly show how you can easily do that on the Devtron. So this is the Devtron UI. So I have set up for this particular demo. If I go to the global configurations, I'll see that it gives me a SSO login service. So I can configure if my organization has a Google login. So I can configure a Google login on this particular Devtron and then give users access based on these and they can sign up using their Google IDs, and they can easily access the services over here. So that is how it's done. So I'll quickly show you how user access is done. So here we have like some group permissions, and then you can also give individual permissions. So if suppose I want to give a group permissions, I'll quickly create a QA. I want to give group permissions for QA. All apps. Okay, so I'll copy this in the description itself and select the project. Project is nothing but when you deploy applications using Devtron, you are given an option to select a project. Devtron can also detect all your Helm applications which are running inside the clusters that you have added. So even if you have not started using Devtron, you can see all those applications and manage all those applications using the Devtron UI itself. So it automatically detects all the Helm applications which are present inside that cluster which you have added. So I'll quickly show you. Unassigned projects are basically those projects that are not deployed through Devtron, so the project remains unassigned for them. So I also have option to select all existing plus future environments in this particular cluster. So I'll select that. So if I add any further environment also, it will give the access to that environment. And also all application, and then I want to give view only access, admin access, or view and edit access. So I can select admin access and then save this group. So this group I have already created, and then I can add users to this particular group. So if I want to add myself to this group, I'll just give my email ID, select this particular group or multiple groups, or I can even give single permissions on a la carte basis sort of thing, and save it. And this will give permissions to me for that particular group. So this is pretty handy when it comes to giving permissions to your teams, because you can create different groups for different teams and keep on adding users to this particular group. So it's fairly easy that way. So in this way, we have, like, you can give access on cluster basis, on project basis. You can also give you can also give access on applications level. So, and we also support like three different permissions level, which are view only, view and edit, and admin access. Those are the three permission levels that are supported. So this is pretty easy. So I'll come to the next part, which is no active monitoring of the resources. So for this particular demo, I'm going to show you install Helm chart using Devtron. So I'll quickly go to there. So Devtron comes with a chart store. So it has all the charts. So we have added some default chart repositories like Bitnami and Elastic. So it brings all the Helm chart. It crawls all the Helm charts from there, and it shows you in this chart store. That what we call it. So I'll quickly show you. So suppose I want to, let's use a SonarQube. Let's use a SonarQube installation. So this is the Bitnami SonarQube chart. So I'll just click on it and then click on deploy. You can select the chart versions that you want to deploy. You can also check the README right here on the left, and then you can click on deploy. So this is the SonarQube configuration file. I'll just quickly give it a name, QA. So SonarQube, and then I'll select an environment to deploy to Devtron demo would be fine. I want to stick to the latest chart version, which is 1.4.6. So I'll configure some things over here. So ingress, let's suppose I want to create an ingress. Yes. I want to have it at devtron.info. SonarQube.devtron.info would be fine to go with. And then I'll give it a class name, which is public. So I already have an ingress controller running inside this cluster, which has the class public. So I'm just using that one, Devtron, right? So, and then I'll also have to change the service type. Load balancer from load balancer. So I'm using the ingress, so I don't have to provision a separate load balancer. So I'm just doing it with node code. Okay. So I'm just going ahead and deploying this chart. Let's see. Okay. Deploys this chart, and now you can see that it's creating all those resources. So you can see this. This is the pod which is getting created. This is the Postgres pod which is getting created. You can see all the uh, resources that are getting created in this grouped UI, where you can see there are 19 resources. And then if I expand this, I can see all the resources that it has created, this particular Helm chart has created. This is just on the single window. I'm seeing that I don't have to group it. It's already grouped. So I have a total visibility of all the resources that are created or provisioned by this particular Helm chart right here on this window. So I can see that it's getting created. If I want to check the events, I can go to the pods and check the events. So it shows me all the events. It says that this particular pod got scheduled on this particular VM. And you can see various Kubernetes events over here. If I want to check the logs, I can click here and then check the logs. I can even grep something if I want to, like, suppose issues, grep issues. Okay, so you even use the grep functionality also to like scan out through the logs and find something. And here, if I can see that this is now healthy, this pod is not healthy. I'm not sure why it is not healthy. Let's check the logs, why it's not healthy. This one is healthy. Okay, let's see. I have already done Route 53 mapping for this one. So it should be up on sonar cube.devtron.info. Okay, so it's not healthy yet because of some reason. Let's see. So this one is in degraded. So probably there is some issue with this pod because of which it is in degraded mode. All right. I see it is in degraded because there was a persistent volume which was created by the same name. So let's do one thing. Let's delete this one. Let's delete this one. It's very easy. Just go ahead and deploy another one. Give it another name so that qa2.sonarcube. This one would be fine. Okay, so just going ahead and deploying with the same configurations. Hopefully this should be done this time because there is no persistent volume from the same name. Okay, so let's wait for this one to get. Meanwhile, I'll show you the capabilities also. So you can go to the log analyzer. If you have multiple pods which are provisioned for this particular deployment, you can select all those pods over here. We also have individual group. So you can also select those pods. So if I want to check the Postgres pod logs, I can do that right from here. So it comes pretty handy when you are analyzing logs of multiple replicas of your application. So it shows you all the logs right on one screen. It's pretty handy. So let's see that if it is able to get it. No, not yet. So this one is still in progressing. It's waiting for the sonar cube to start. Configuring user credentials, stopping small group. Learning sonar cube. I think it should be up now. Okay, it's up. Took some time, but it's finally up. So as you can see, the Sonar Cube is up. I'll quickly get the password. So you also have an option to get inside the container. So I'll get inside this container to see the password. Print environment, then grep for password. Okay, so this is my SonarQube password. Let me paste that. User is probably user. Let's see if it is able to sign me in. Okay, perfect. Right, so that's a SonarQube Helm chart. So I have just provisioned on a Kubernetes cluster. You can see how easy it is to do that using Devtron. I'll quickly show you what I meant by active monitoring of resources. So if you see that there are two pods, so one is this and one is this one. If I delete this one, so you see the application status as healthy, right? So as soon as I delete one of these pods, right? So I'll wait for it, and the application status goes to progressing, right? So if I click on details over here, sorry, if I click on details over here, it will show me what are the resources because of which this particular Helm installation is, Helm deployment is degraded or in progressing state. So that's how it is showing me over here. So this is like active monitoring of all the resources. It Devtron actively monitors all your resources, even after the installation, even after the deployment has happened. So that's one thing. So I'll show you some more. So next in the line was no proper grouping of resources. So I've already shown you how uh, Devtron groups these resources. So if you can see that under workloads, you'll have deployments for replica sets, stateful sets, if there are any. Under networking, you will have endpoints, ingresses, services, if there are any, and then config and storages, persistent volume, claims, secrets, and config maps all come under config and storage. And if there are any RBAC elements, you'll find it under RBAC, and then there may be multiple custom resources present in your Helm chart, so you'll find them under custom resources section over here. And then referring to the README, so I skipped this part, so I'll quickly show you. When you are deploying your application, you can quickly refer to this README on the left side. So you can check what parameters do what things on the left pane itself, and then make the changes accordingly on the right pane, right? This is very convenient instead of switching different windows to switch the context and then do it on your terminal. So it's pretty easier to do this way, right? And then you also have an option to compare the values. If there were any changes, recent changes, it highlights all those changes that you have done. This was a single deployment, so it's not highlighting any changes. And then also you can check what would be the output of Kubernetes manifest that it generates. So if I deploy this particular Helm chart, it generates these Kubernetes resources. You can check if a particular thing is not getting rendered properly this way. That's easier to debug in this fashion. And then I have to cover out of the box support for hibernation, right? So I'll quickly show you that. So if I click on here, scale workload. So I have an option to like scale down my workloads, right? So if I select all the workloads and then click on scale workloads to 0, it will like scale down all my workloads to 0. So my application status goes to hibernated, and it will remove all those pods. So text sign. So it has removed all the pods yet. No. It will take some time and it will just scale down these workloads. Right. So now you can see that there are no pods. Right. So it has scaled down all the pods. So if I'm doing a POC, temporary POC, and suppose I am doing a POC with a Elasticsearch Helm chart, and it of course requires a lot of resources on your Kubernetes cluster, maybe 2 or 3 worker nodes to have a full Elasticsearch cluster, and then I want to pause my POC, of course, on a weekend. So what I'll do is I'll just scale down my workloads on a weekend when I'm not working with it, and then I'll come on Monday and select all the workloads and then restore my all the workloads back again. That saves you a lot of cost on your Kubernetes infrastructure, and then you already have cluster autoscaler working in action to scale down all the unnecessary instances that are up on your cluster. So you can also do that. So I have scaled the resources back again. If you can see, it's spinning up the pods again. So it's spinning up the pods again. So I'm going back to the presentation to see what exactly is left. So no active monitoring. I've already showed you how Devtron does that. No proper grouping of resources. This I've already covered. How Devtron groups all the resources. On the left pane, if you can see here, it shows in a neat UI what are the resources and various categories. So that is also covered. Referring to the Helm charts and README again and again is not a hassle again. You can refer to the README on the left pane and then do the changes on the right pane accordingly. So that's also covered. Unified interface for managing Helm applications. So this one I would like to show you. So you can add as many clusters on one Devtron installation as you want, right? So you can add multiple clusters. You can add multiple clusters from various cloud providers, be it GCP, AWS, Azure, any cloud provider. And then all the Helm applications that are running on those particular clusters will show up right here on this particular UI. And you can also manage access and give access to relevant users only. So that is also doable right here on this UI. So if I get an access for, let's say, QA clusters, I will only see the Helm deployments that are running in the QA clusters. And I won't see any application which is running on production or on dev clusters. So that's how you can manage the accesses. So right now this cluster has only one, which is the default cluster, which is where this Helm application is running on. So it's not showing any other clusters, but you can add multiple clusters on your deployment. Okay, so coming back to it. So hibernation, this I've already covered. You can hibernate your workloads when not needed and scale up the workloads so when you need them back again. And then deployment values comparison, like I said, that it's a hassle when you're using long values.yaml files to actually compare what were some changes which were done like 5 days back. But with Helm, you can with Devtron, you can always see what were the changes which were done on those particular deployment dates, and then you can if you want to roll back those changes, you can do that. If you want to make some edits in those changes, you can also do that and send a new deployment. So that's also covered over here. So this module of Devtron, which I just showed you, is just a base stack of Devtron. We support multiple integrations also with Devtron. So one of the coolest integration is the CI/CD integration, which lets you create a full-fledged CI/CD workflows on top of a Kubernetes cluster. So you can build your images right from Devtron UI. You have cool integrations like with SonarQube. You can integrate your uh, uh, deployment pipe build pipelines with SonarQube and get the scans done. And you can also scan your images for any sort of vulnerabilities that are present in your images. All those things you can do using the CI/CD integration of Devtron. So it's just one-click installation, which happens right from this cluster, right from this base stack. So that you can do, and then you'll need to configure a couple of things like we use Argo CD, and we have a GitOps implementation along with Argo CD when you install the CI/CD plugin. So you'll need to provide those credentials over there, and then you'll are ready to go and do that, use that. So we also support multiple deployment strategies. So we have blue, green, canary, rolling, and then recreate deployment strategies that are supported by the CI/CD plugin. You can I'll also show you, if time permits, I'll show you how a CI/CD integrated Devtron looks like. Uh, then you can also deep link any external application. So if you have a Grafana setup or you have a Kibana setup and you want to integrate directly, deeply integrate directly with the applications that are running on Devtron, or you can also do that. So that if you're checking an application and you want to check the logs of those particular application, you can directly click on the Kibana link on top, and it will directly take you to that particular application's log on your Kibana. So those sort of deep integrations are supported in the CI/CD integration as well. And then you also have some deployment metrics that are also visible to you. If you want to see the CPU usage, memory usage, and latency, 4xx, 5xx, HTTP errors and all. So that's also you can see on the Devtron dashboard itself for those particular applications. So this is some more information about the Devtron project, which is the open source project. Our entire team is available on Discord always. So you can always have your questions answered about the Devtron product itself, or about any Kubernetes problem that you might run into. We are always available on Discord. You can ask your questions in the Devtron forum itself, Devtron open channels itself. We have some amazing enterprise users also, like I mentioned in the beginning, which are using Devtron for orchestrating their microservices on a Kubernetes cluster. Delivery, Bharat LiveSpace, Mocklex, Zotace, and Ernst& Young, Unity Bank. These are some of those clients which are already actively using a Devtron for the installation. And then I think I can have some questions now.
Hey Prakash. So yes, we do have some questions. I'll flash it on the screen.
Some questions, if anyone has some sort of questions.
So the first question is: Devtron manages Helm chart for organizations or complete K8's cluster? Am I audible, Prakash? Prakash, you there? So it seems Prakarsh has disconnected. no issues. So Prakash is facing some technical issues. So if you want to reach out to Prakash, if you have any questions, you can reach out to him, or Prakash can will answer all your questions in the comment section itself. All right. So before we go to the second session of today's meetup, just a gentle reminder that we also have a quiz. You can participate in the quiz and get a chance to win vouchers worth 200 INR. And I'll also paste the link here again. And go. Make sure you have registered. Quiz starts after this session itself. All right. So let's bring our second speaker of today's meetup, who is Dinakar, and who is a runtime optimization architect at Red Hat. Hey, Dinakar. Yeah, your microphone is on mute, Dinakar.
Oh, sorry. Hey, hopefully I'm audible now.
Yeah, you are audible. Yes. Hey, how are you doing?
I'm doing good. Thank you for having me here.
Yeah. So, before we go further, could you please, Dinakar, tell us a bit about yourself and the topic that you're going to present here today?
Yep, sure. My name is Dinakar. Work at Red Hat. I've got about 25 years of experience. Mostly 22 of them are at IBM, where worked in a number of roles. I used to work in Linux kernel, open source for almost about 10 years. Then I was a solution architect for a couple of years. Then another decade of working on runtimes and optimizing runtimes, specifically Java for cloud. And then me and my team, we all moved to Red Hat, and that's where I'm at right now, and I'm continuing to work on that. So my primary job is to work on tools and utilities that help runtimes run better in the cloud, and get the kind of performance benefits, or performance that you need. Most of the times Asaris find it really difficult to tune Kubernetes, because first thing is they're new to Kubernetes, and there's also runtime challenges, and that's present. That's what I work on, and that's what I'm going to be talking about today as well.
Awesome. So, yes, you've shared your screen. All right. Over to you, Dinakar.
Yeah, thank you. So yeah, as I mentioned, I'll be talking about step by step, what are the things that you can do, starting from the most basic aspects to some really advanced tools and utilities that are out there to get the best performance for your application running in Kubernetes. So let's just get started. So, has it ever happened to you that when you talk technology to your customers, only for them to ask, what's the mileage? So we in India are always worried about kitna deti hai than anything else. So today we'll be looking at ways to improve the mileage that you can get from your Kubernetes cluster. So let me take a moment to define what I mean by performance. So traditionally, performance looks at three key aspects: throughput, response time, and utilization of system resources. And this is what I'll be talking about today as well. But I'll be confining myself to compute only, as in not really touching upon network and disk and so on. I thought it'll be nice to define the problem statement here. What are we really trying to achieve with the 10 steps that I was mentioning? So let's imagine that you are an SRE, you're running a Kubernetes cluster. and you've been given this particular problem to solve. So you have a complex polyglot application. In this particular case, it's a airline booking system. As you can see, it has a number of microservices, and each of these microservices may be written in different language runtimes and frameworks. Here the web application is in Node.js, and the backend booking service is in Quarkus and Hotspot. Something else can be in Spring, and so on. And so this is typically how applications are written these days, each microservice being tuned for a specific use case, and the language runtimes being chosen to handle a certain kind of workload. So the problem here is that the user is having a slow response time, let's say, while doing an airline or flight booking. And so the question here is, what can the SRE do to optimize this entire path? The request lands on the web application, then the booking service, and it might touch on some databases and so on. So this entire path needs to be optimized so that they can get a better response time. So that's the challenge that we have here, and that's what we'll try to solve. So if I have to do a launch countdown, so this would be the step number 1, or where we are talking about the 10 basically in the countdown. So the first thing is that you look at the observability. So it doesn't matter how much you try and optimize your applications. If you haven't set up observability properly, then you might actually end up tuning all the wrong things, right? So you need to make sure that you're monitoring your system. There are a number of metrics that need to be carefully looked at. How much CPU, the node at a node level, how much CPU and memory are you using? How much of it is free at a cluster level, at an individual pod level? And within the pod you have application, and you might need to turn on metrics within the application. So these days we can have really sophisticated tracing mechanisms, and in fact you might be able to even use advanced AI capabilities, which we'll talk about, to actually arrive at what is exactly the problem from a performance point of view, and how that can be optimized. So there are a number of tools, things like Prometheus, Grafana, and Jaeger, and so on, that help you from an observability point of view. One thing that I really request you to check out is the OpenTelemetry project. OpenTelemetry is a open source industry standard. It is, it's still a little bit nascent. I think only the tracing has gone GA as of right now, but the metrics, logging, and so it's trying to put together all aspects of observability: the metrics, logging, tracing, and so on. So this is, even though it's in its early stages, this is going to be picked up by most of the major vendors out there in the near future. So OpenTelemetry is something that you should definitely keep your eye on. Another thing is, when you're setting up, let's say you're setting up your own Kubernetes cluster, the question is always in terms of a granularity of observation. There's always a trade-off between, let's say you have set up a granularity of observation of 1 second. So that means you can really accurately figure out what's going on in the cluster, but that might be at the cost of really high overhead, because you have lots and lots of data coming in every second. So there's a trade-off here, and you need to be careful in how you set that. And there's also a number of other application level metric providers that you can turn on that can provide detailed analytics that can be used to tune your applications. Things like Quarkus micrometer, Spring actuator, Node.js has prompt client, and so on. So this is essentially the first step, making sure that you have set up the right kind of observability in your cluster. So the next step is, of course, if this is only if you have access to the hardware. Let's say, it can be a bare metal cluster, or even if it's on the cloud, you most definitely have access to the nodes. So this is something that sometimes people forget, but it can have a big impact on the performance as well. So at the node level, you can tune or you can make sure that the node has been set up for performance profile. So for example, if you're running Linux on your nodes, there is something called as a scaling governor, which is accessible out here, in this path, for example, and that shows that there are two different governors available: performance and power save. Power save is something that you would choose if you obviously you want to reduce your power costs, for example. But if on the nodes that you're really interested to run applications which are very performance sensitive, you need to make sure that this has been set up for performance. Another thing that I've seen a lot of customers get wrong is when it comes to hyperthreading. So a hyper-threaded CPU is not really a full-fledged CPU. It can give you at most 20% performance of a full core. So for example, if you have two hyperthreads, a single core with two hyperthreads, that can, that doesn't give you the same performance as two cores, right? So it can only give you 1.2 or 120% or 120 times that 120 of a single core. So it's just 1.2 of a core and not two. It's not equivalent to two cores. So this is something that you need to be extremely careful while doing capacity planning. So if you're thinking that, I've got 6 CPUs out here and they happen to be hyper-threaded CPUs, so you really don't have those many number of CPUs. So this is something that you need to be extremely careful when you're planning for performance. So the next few steps, if you look at, if let's say that you assume that you've set up your observability and you've set up your hardware, so the next step is node affinity. So what is node affinity? As the name mentions, so it helps to match workloads to the right resources. And this is something that is typically accomplished by setting the right labels to a node in a Kubernetes cluster. And so this is very useful if you want to assign pods to specific hardware features on the node. For example, you might have ML application that needs GPUs. So there might be only certain nodes which have this GPU hardware in them. So you need to make sure that those nodes have a label that says something like, this has GPU, as you can see out here. So this is a YAML that can help you to do that. This is meant. The name here is MLHPO. So this is meant for, let's say, machine learning workloads, and this has affinity field out here in the spec which says that this has the value of GPU. So when you're assigning your pods, you can say that make sure that this runs only on nodes that have the GPU capability, for example. So this ensures that your application gets the right kind of resources, and so that the application performs well. So that's node affinity. But there is also something called as pod affinity. Pod. So for example, the common example here is pods that commonly communicate together, or maybe they share some common resources. Then it makes sense for them to run on the same node. So we can use pod affinity rule, as can be seen out here, to make sure that they run all on the same node. So in this particular case, it says required during scheduling, ignored during execution. Required means that this is like a must-have. So this means that this the pod that you're trying to schedule, it will only be scheduled on nodes which have other pods which have, let's say, for example, the same security feature called S1. So you maybe they all share maybe the same security profile, and so you want all of them to run together. And so this way you can specify. This way you can make sure that the pods having all the same security policy are running on the same node. But you also have a situation where maybe you don't want pods from one application A to run on a node if you have pods from application B also running on that node. Maybe because both application A and application B, both of them use GPU extensively. So if both of them are hitting that at the same time, it might not give you good performance on both, and so you want to separate them out. So in that case, we can use something called as pod anti-affinity. So here you're making sure that only when the pods so in this example, we want a pod to be scheduled on a node only if there are other pods that have the same security policy S1 and don't want to schedule it on a node that are running pods that use security policy S2. So that's this whole YAML out here. So this takes care of both the affinity and the anti-affinity. So, the advantage with this pod affinity and anti-affinity is that it allows the admin to dynamically assign nodes for certain kind of pods without having to dedicate nodes ahead of time. So, if you see without pod affinity and anti-affinity, how you can accomplish this, you can accomplish that using just node affinity alone. But then you have to dedicate saying, I have 3 nodes, and one node I will make sure that all pods with security policy S1 are running. Another node I'm going to dedicate it for S2. But then if something goes wrong with those nodes, I have to it's a tough thing for me to then manually having to figure this out. But then if we use pod affinity and anti-affinity, the Kubernetes scheduler will automatically take care of this, even if there are nodes coming up and down. It'll ensure that the right set of pods are running together, and the right set of pods are not running. The wrong set of pods are not running together in case they happen to be hitting on each other and things like that. So that's the next step. Let's assume that now you've set up your pod affinities and your node affinities, right? So now we come to the most important aspect of performance tuning. So this is all about right sizing the application. So right sizing an application, greatly helps to get the best performance. And the way that you do that is by setting the CPU requests and limits and the memory requests and limits. So here we have an example YAML that you can see on the left. So here you see that there is a resources section where you can specify requests and limits. So you might be aware that there are 3 QoS classes that Kubernetes has. So there is a guaranteed class, burstable, and best effort. So when you have not set anything at all here, so let's say the resources field is completely missing in your YAML, that is corresponding to a best effort. So that means you're not asking Kubernetes for any amount of resources. You just say, run this pod. And so Kubernetes might run it anywhere, wherever it might find some free resources. But there's no guarantee that it will continue to run on that. It might get bounced around. And if there is any kind of resource constraint, these best effort pods are the ones that might get killed first. So you should never run a pod as a best effort pod. So what is guaranteed? Guaranteed QoS class means that you're setting the request and the limit to be the same. So you know, for example, that your application will never go beyond 500 MB memory, and it'll never go beyond 2 cores. So in that case, you can set both the request and the limit to be the same, 500 M and CPU is equal to 2, in which case Kubernetes says, okay, I'm going to find a node where I can find 2 free cores and 500 MB of RAM and schedule your pod on that. And it is guaranteed to be given that many amount of resources at all points in time. But most of the times what happens is it's very difficult to say that it'll always, the application will always be within that constraint. Sometimes, like for example in Java, what happens is that whenever there's a garbage collection, let's say, so you might get a spike, or maybe when you see a load spike, you might see a corresponding CPU spike as well before it tapers off and levels off. So in these kind of cases, so in most cases, I would recommend actually using burstable QoS class, where you have requests that take care of your normal operations, and limits are over and above requests, where that will take care of any spikes that your application might have. There's another thing called as a limit range. Sometimes administrators would set a limit range for a particular cluster to make sure that nobody, the general users don't end up consuming more resources than is what has been mandated by a department, let's say. So in this case, some administrator has set up a limit range that says, by default, I will only provide 1 core and 512 meg. And that's the limit, and the request is going to be 0.5 core and 256 meg. So that has been set as the default for the entire department, let's say. But then maybe your particular application might require more, so you need to make sure that limit ranges don't come in the way of applications that really need lots of CPUs and memory, and so you need to plan accordingly. The next step is now, we just noticed all this while that right sizing, as I talked about previously, that is really crucial, because if you give a pod less amount of resources, that might end up ooming, or it might not get enough CPU, and so that means that the application gets throttled as well. So clearly it has a big impact on performance. So the question is, how do we know what's the value to set for these requests and limits? What is the right value? How do I know what is the value to be set to determine what how much does my application need? So this is a not so easy question to answer. Kubernetes does have a few set of tools for you to to be able to figure this out. So let's look at that in a little bit of detail here. So the first thing is, we have something called as the vertical pod autoscaler. So this is the one that will help you to actually right size. But actually, I have another tool called as Cruise, which I will be talking about in a minute. But the VPA is something that is available in standard Kubernetes, and it allows you to, it basically monitors your application over long periods of time, and then comes up with a recommendation based on the observed interval that what should be the values for the requests and limits. But that's not really a smart way of doing things, and so that's where Cruise comes in, and I'll talk about that in a second. But there are a couple of other scalers here. One is the horizontal pod autoscaler, and the other one is the cluster autoscaler. So the horizontal pod autoscaler, obviously, I think this is something that almost anybody who's been introduced to Kubernetes will be aware of this, because it's probably one of the most popular demos where you're shown how you can auto scale up and down. But there are some best practices here. A lot of the times, most of the people, what they end up doing is just doing the scaling on the basis of average CPU utilization, for example. But that might not be a smart way of doing things. So, for example, if you set up a policy that just says, every time my average CPU utilization of a pod goes beyond 50%, start a new pod. But that can happen due to any number of reasons. For example, as I mentioned, in Java, you have a garbage collector going on that might give you a spike, and your CPU might shoot up beyond 50%, which might end up scaling another instance, which is really not needed at that point in time, because the incoming load might not have changed all that much. So a better thing to do is to use metrics such as packets per second or requests per second. So these are standard Kubernetes metrics. So in this particular case, what we are saying here is, if the packets per second for this particular pod, the average value of the packets per second for this particular pod goes beyond 1K, then start another instance, which makes a lot more sense, actually. And similarly, if the request per second goes beyond, let's say, 10K, then start another pod. So I think these are much better ways of setting up the the HPA, rather than just a basic CPU average utilization metric. You can also use application-specific metrics. So these are, as I mentioned, standard Kubernetes-specific metrics. But you can also use a application-specific metric. Let's say your application is keeping track of how many concurrent connections it is handling at any given point in time, the application inside a pod. So you can say that if the an external metric, which is the application-specific metric, called as concurrent connections, and it tells how to get this value. That is, it's specifying that the connection equal to current, and so this should be available from the pod. If this value goes beyond 1200, then start another instance. So this can also be used, but you can imagine that this has a higher overhead, because this is not native Kubernetes metrics. These are application-specific metrics, and so there's a little bit of an overhead involved here. So the best practice is to try to use Kubernetes-specific metrics as much as possible. And the last thing I want to mention is from the cluster autoscaler perspective. So you have something called as a pod disruption budget. So I mean, commonly, one of the mistakes that people do is that when they're scaling up, they've set up, beyond certain values, that you start a new cluster, for example, which is fine. But then when the scale down happens, it might end up causing performance issues, because it might accidentally scale down clusters that should not be scaled down. So to prevent things like that, there is a feature called as the pod disruption budget. So the pod disruption budget can be used to say how many clusters will be unavailable, or rather, how many nodes will be unavailable at any given point in time. So this is something where, I mean, in this particular case, there's only one node which is unavailable at any given point in time, and so you will ensure that, let's say, for example, you've set this to 2 or 3 or whatever that is, those many nodes are not touched, essentially. Okay, so now the thing that, all these things that I just mentioned so far, all the set of tools and utilities and Kubernetes features that we have seen so far, these are all sort of the basic knobs that Kubernetes has, and these are absolutely something that you should individually look at and very carefully look at and set that specific to your use case and your particular cluster. So once you've set up all of them, but you might find that you still are not getting the kind of response that you need from the application. So, I mean, if you look at a non-Kubernetes world, what used to happen earlier was, we used to have all these bare metal clusters or virtual machines, and these were being heavily tuned by the IT admins. You have admins who know every aspect of that box or virtual machine, and they tune every little aspect of it, including the application stack. So most of the times, you might have let's say an Oracle application, or a Tomcat server, or Apache Tomcat, or WebSphere, IBM WebSphere, or Oracle WebLogic, or something like that, in an enterprise environment, and they have their own clusters. So you can really tune every aspect of that. But now you're running in Kubernetes, and the thing that gets missed out most of the time is how to tune the runtimes themselves. So this is something that is a really very rarely explored part of tuning within Kubernetes clusters right now. And the reason for that is, there are just way too many knobs. It's not specific to any one particular application type, right? So it's not Java application. You can have a Java application, you can have Node.js, you can have Python and Rust and Golang and so on and so forth. So everything is all mixed up in a Kubernetes cluster. It's not a homogeneous cluster. There's no single way to tune all these application types. And even if you have something like Java, where it has lots and lots of tunables, you're afraid to touch any one of them because nobody knows how it runs inside of containers. So even if you look at some of the vendors, including Red Hat, that provide OpenJDK, for instance, there's very little documentation around how Java runs within containers and what kind of tunables can help. And there's lots of debate going on even now on Twitter, for example. Somebody says, oh, do this kind of setup and for your containers, and so on. So this becomes an extremely painful aspect if you need to start tuning your application inside of a Kubernetes cluster. So this is probably how it looks like for an SRE, that users are complaining that even after I've set up all the Kubernetes cluster in the best possible way with all the stuff that I mentioned so far, users are complaining that it's really slow. You have finance maybe saying that, oh, we are using too many resources, I can't give you any more resources. Developers say they have lots and lots of options that are available. Oh, did we lose the? Sorry. Okay, I think we're back. Okay, so developers do have lots of options when it comes to runtime tunables, but the question is, how do we bring all of these aspects together? Okay, so that's where we have this project that I'm working on. It's called as Cruise Autotune. It's available on public GitHub. You can look at github.com/cruise/autotune. So this really helps you to do all this automation, do all this optimization in an autonomous way. So very quickly, this is how the Autotune architecture looks like. So we have a YAML, which the SRE or the IT admin can provide, where you're capturing the objective function. So it's like, what exactly is it that you're trying to optimize for? Maybe you have multiple objectives. Like, for example, I want to get the best throughput, but at the same time get the lowest response time and for the lowest amount of cost. So you might have multiple such objectives which might be competing with each other. So you can mention all of that as a arithmetic expression here. So you can have weightages that says, okay, I want to I give more weightage for my response time, lesser for my throughput, and more weightage for my cost and things like that. And I'll say that, okay, I want to maximize this entire arithmetic expression. And you can explain this arithmetic expression in terms of these function variables. You can say that, so this can be of the form, let's say, a squared divided by b plus c or something like that. And you can define what a, b, and c are in the function variables. So a, b, and c are defined as Prometheus queries. So this becomes a Prometheus, metric provider that's running inside of your Kubernetes cluster. So you can use the query given here to get that particular metric A. So this whole thing is needs to be maximized, let's say, and this is to be applied for a particular deployment that you have within your cluster. Let's say I'm running a Quarkus application, so I want to tune and get the maximum throughput or whatever objective function that I have for this particular value. So when I apply this to the cluster, we have AutoTune running, which will talk to Prometheus here and figure out all the pods relating to this particular deployment, and figures out the layers of the stack. So for example, this application can be a Java application which is running Quarkus, or it can be Spring Boot application, or it can be a Node.js or Python and so on. So it can figure out what are the layers in this application. So once we have those layers, we have a library here that has tunables for each of these layers. So for hotspot JVM, we have a bunch of tunables. For Node.js, for OpenJ9, and so on. So we have a bunch of tunables for each of these runtime components. Similarly for Spring Boot or Quarkus and so on. So we match these tuning sets to the layers that we have found here, and that becomes our search space. So this search space is then passed on to what is called as a hyperparameter optimization algorithm. I'll just talk about what that is in a minute, but this is essentially implementing what is called as a Bayesian optimization, which gives you a config to try out. So you've given it a range of tunables. It says, okay, here are all the tunables, and here are the ranges within which they operate. So for example, you can have CPU ranges from minimum of 0.5 core all the way to 4 cores, memory, so on and so forth. And then a hotspot has a bunch of tunables, and they have ranges and things like that. So we provide all of this in the search space, and this one will give you a specific configuration. So it says, okay, for CPU, try this value. For memory, try this value. For this hotspot variable, try this value, and so on. So that is the config experiment. And we have what is called as an experiment manager module here, which picks up this and then does a deployment rolling update onto the pod to get a training pod which has that particular configuration. And then it monitors this pod. The user has to apply a load onto this pod, and the experiment manager will monitor the how this particular configuration does. And at the end, so let's say, for example, that trial will run for about 15 minutes or something like that. We parse the results to say, how did it do for this particular objective function? We, all the queries that we have here, we query them and find out how did this objective function do for this specific config experiment. And that's returned back to the Bayesian optimization here, which will give you another configuration. And we do the same thing here. So it goes on in a loop. We do about 100 trials, which can run for a couple of days, for example. But at the end of that, you get a configuration that gets the best performance for this particular objective that you started off with. And that is what is returned back to the user, essentially. So now I do have a quick demo here. So I have a Minikube running on my laptop. And if you see the services that I have running here, there is AutoTune running in the cluster. I have Prometheus installed, and I have a database here, a Tech Empower benchmark running here. So this is the, it's an open source benchmark called Tech Empower. You might have heard about it. I'm specifically using the Quarkus REST-easy Hibernate benchmark. And of course, it has its own database. And so so this is accessible on this particular port. So the goal here is to optimize this particular benchmark to get better response time. So if I look at this, for example, so and by the way, all these are available publicly, so you can actually run these demos on your laptop. So I'm trying to apply this particular YAML. So this YAML is saying I want to minimize my response time. Response time is nothing but request sum by request count. Request sum is this particular query here, Prometheus query, and request count is this particular Prometheus query. So this divided by this will give me response time, and that needs to be minimized for this particular deployment, application deployment. So this, as you can see here, I've set up a watch on this particular application that's running. So now let's try to apply this. So here you can see that it's of type kind auto tune, and so this is what gets applied. So when I apply this, you'll see that this application starts to get restarted with the configurations that the Bayesian provides. And we can see what's going on here using this particular API. So here you can see it's running the first trial. We can look at what are the values being used here. So you can see it's trying with CPU value of 2.6 cores, memory of 242 meg. Both requests and limits are the same, and it's also running with a bunch of Quarkus variables. So this is the stack that is getting tuned. So it has found that Quarkus is one of the layers, and it is figured out the tunables for that, and it is setting some specific values for these tunables. So so now that we have this running, you see that there are multiple such trials going on. So it first it did the trial number 0, and then it was running trial number 1 with a different set of values. You see that these values keep changing for each of these trials. And if I just refresh this, it tells you how many. I mean, okay, this is just a dummy thing right now because I'm only running it for 10 seconds just to show this demo. So it has already finished, 9 trials here, 8 trials here. The 9th one is ongoing right now, and you can see that it calculates the best trial at the end of all of these. Once it finishes running all these trials. I mean, there are a couple of things that we also take care of here. So for example, if you look at all the tunables that we have, so we also take care of things like the heap size inside of Java as well. So, you might be aware, I mean, people who work in Java might be aware that the heap size is a function of the container limit. And so if you change the container limit, you need to dynamically change the heap size as well. So we monitor the heap size as well as the CPU and memory being used by the pod for each of the trials while we are running, and then automatically suggest the right request and limit values as well as the heap values as well, in addition to all of the Java parameters, other Java configuration parameters and tunables as well. Okay, so now just going back to this here. So I mean, if you ask me what this Bayesian is all about, I normally compare that to Jenny. So where you ask a Jenny a wish saying, oh, lower my response time, and that's exactly what it does. But what ends up happening is that sometimes it might be at the cost of something else. So for example, if you say, I want to lower my, give me the lowest possible response time, the Bayesian will find out the best configuration where you get the least amount of response time, but it might end up suggesting something like, oh, a large amount of CPU to accomplish that, which is something that you might not want to have. So you need to be extremely careful what you wish for, and try to combine all of your wishes. So you can say something like, I want to be on a beach in Hawaii with my wife and kids, and walk into my large house with this great internet connection in my F1 Ferrari car or something like that. So you're combining all your requests into one expression that can be used to give to Bayesian, and then it can try to fulfill all of that in one go. But if you just say, I want a really big house, it might put you in Antarctica, which is not what you want. So let's look at what we did here with the AutoTune tool and some of the results that we obtained. So we ran with these 31 tunables here, with, a number of hotspot tunables, a few CPU, container from a container layer. It was just the CPU and memory. The JVM had all these tunables. Quarkus had these mentioned out here, and these were the the defaults of each of these tunables and the ranges within which they operate. And we were running this in a OpenShift cluster, and the Tech Empower framework benchmark that I was showing you earlier. So for this particular experiment, we kept the requests and limits to be the same, and fixed the GC as the given GC policy, and max RAM percentage, which is the heap size, was also fixed to start off with, and the load was kept constant. So this was essentially, so we actually did multiple takes to get all of these values. You can get them out here. So this is on public GitHub, github.com/autotune. This is our autotune repo. The demos repo is available out here. This is the demo that I'm running right now. So you can actually run it on your laptop, autotune minico demo setup.sh. And the results are available here publicly as well. So if you look at Tech Empower, for example, it gives you the results of each of these experiments that we ran. How well did we do? So this is the AutoTune provided configuration. This is the default configuration. And how did each of these experiments run? And each of the trials. So for example, in this case, we ran 100 trials, values for each of these trials, and so on. So this is exactly what I have out here as well. So here, so the problem that happened was that we initially said, give me the best response time, but then it turned out that it gave us a very good response, but then it was using lots of CPU. So the default was using only 4 cores, whereas AutoTune provided configuration was using 8 cores. So this is not ideal, right? Because that means that the cost is increased as well. So then we said, let's try to fix the number of cores. We don't want to use more than 4 cores. Give AutoTune only 4 cores so that it can operate within that range. And then we ran another set of experiments. Then we realized that the next time the max response time was not max response time is, it's also called as the tail latency, for example. So most of this is the average response time. So most of the times we are responding back to the user in 0.28 milliseconds, but sometimes the max response time goes higher than what the default configuration provided. So we said this is not acceptable. We want the max response time to be lower than the default. The CPU cores have to be the same or less than the default. We still want better response time and better throughput as well. So that was what it was. That is the take 3 that I have here. Each of these experiments are available on the AutoTune results repo that I showed you. So this one has all of this as part of the objective function. As you can see, we want a very good response time. Throughput has to be better. Max response time has to be as low as possible, and we are fixing the resources. So in this particular case, default was when we, this is with no configuration changes. You ran the application as it is in the cluster, and it was responding in 14.21 milliseconds. The AutoTune, the best config that we got was 2.39 milliseconds. Of course, we validate whether the configuration that is provided here is recreatable, reproducible. So you keep running with the same config to make sure that it actually gives you the response time that you're seeing here all the time. So this was, the results are here in experiment 10. You can see that it actually meets all of the expectations that we had. And it also actually helps to reduce the cost as well. So when we scaled it to handle 1 million transactions per second, the overall amount of resources that it used to handle 1 million transactions, that requires multiple pods of this kind of configuration, we found that it reduces the cost by about 8%, assuming that we're using a A1.extra large configuration, 4-core 8 GB kind of a thing. So this was the best configuration that AutoTune gave us. So this corresponds to each of these parameters that we started off with. What are the values that we see here? And this is the one that I said that we were able to reproduce. So with this configuration, we were able to reproduce this result. It was around the same thing, around 2.39 milliseconds. So in summary, I think we were looking at the countdown. There are basically 10 steps. You start off. The first one is observability. Make sure that you set up the cluster in such a way that you can observe all of the aspects, whether it comes to node level or cluster level or individual pod level, and drilling down into the application metrics themselves. So that is the most important step here. If you have access to the hardware, you need to tune that. You need to be able to set node and pod affinities, set the requests and limits to the right values. You can actually use AutoTune to be able to do that. Make sure that you use app-specific scaling metrics with HPA, for example, horizontal pod auto-scaling, if possible. But the recommendation is to always use Kubernetes metrics that are available using standard Kubernetes. And you can use pod disruption budget to make sure that there's no disruption in performance just because you're scaling down. So that's pretty much all I have. And if you're interested, you can always look up all of the Cruise repos. It is open source, and we do welcome your participation in whatever way. We have a Slack. If you want, you can hang out on our Slack, ask us questions on anything that you have. You can also mail us at cruise@redhat.com. If you're looking to contribute out here, there are a number of really exciting things that we are working on. The hyperparameter optimization that I just mentioned here. There's some really cutting edge work that's going on in this space. And if you want to check out, you can look up this particular repo. And if you want to contribute to any of these reports, you're absolutely welcome. So thank you, and that's all I had for today. So if there are any questions, I'll be glad to take them now.
Sorry, I was talking on mute. Hey, Dinakar.
Yeah, I can hear you now.
Yes. So first of all, thank you for such an insightful session. And we actually don't have any questions in the comment section. But if you guys want to reach out to Dinakar, you can reach out to him. As you can see, he has displayed the links, and you can all his socials have also been mentioned in the description of this video. You can reach out to him if you have any questions or query. And yes, thanks for joining us and upskilling us, Dinakar.
Yeah, you're welcome. Yeah, thank you so much for the opportunity. I'm really, I'm really glad that I was able to, reach out to everybody here. And absolutely, if there are any questions, I would be, more than happy to answer them. So do reach out on Slack if you're interested.
Yes, we Jeevan is asking if it's possible to share the slides. So Jeevan, you can reach out to Dinakar and he can solve your queries.
Yeah. I mean, yeah, these I can make them available on SlideShare. So yeah, I can put them up there. Sure.
Yes. Thanks, Dinakar.
Yeah. Thank you so much.
Yes.
Okay.
All right. So it's the quiz time. I hope you all have registered. I'll paste the link to the quiz again. So we have a quiz, and the top five of the quiz win vouchers worth 200 INR. And make sure you've registered on the Quizzer platform to play the quiz. All right, I pasted the comment to register. Begin the quiz in 1 minute. Also, before the quiz starts, I'll take you through some guidelines of the platform. So, for a smooth experience on this platform that is QuizUp, we recommend you to use either Google Chrome or Safari. And in case you get dropped out from the quiz, please join as soon as possible. And let's say if you get dropped out and you join, you will be allowed to play from the next question onwards. We also request you to not be on VPN as it might affect your bandwidth. You might face some lags, and avoid refreshing your screen unless and until it is very, very important. All right, so we will start with the quiz soon. Before that, we start with the quiz. Let me also tell you about the Devtron blogathon contest. So, if you are a technical writer, you love to write about tech, do check it out. There are amazing prizes to be won. The link to the blogathon contest has been pinned in this live chat and will be pasted here again in the comment section. All right, so we'll be starting with the quiz. Do share it with your friends since this is a live quiz. They might miss out on some points if they join late. So do share it with them as soon as possible. All right, so the first question will soon be on your screens. The time is up, and the correct answer to the question was pod, and refer to the explanation seen on your screen. And like this, we'll be moving forward to the second question. The time is up. The correct answer to this question was CI/CD pipelines. You can refer to the explanation seen on your screens. All right, moving on to the next question. The time is up. And the correct answer was avoid downtime. You can refer to the explanation seen on your screen. Going to the fourth question now. The time is up. And you can see the correct answer and the explanation on your screen. Moving on to the fifth question now. The time is up. The correct answer to this question was Kubernetes operator, and 55% of you answered it correctly. So we are halfway through the quiz. All the best for the next 5 questions. The time is up. And the correct answer to this question was it must be included in the app's code. Going to the next question now. The time is up. You can see the correct answer and explanation for the same. Let's go to the next question now. The time is up, and you can see the correct answer and explanation on the screen. Around 81% of the participants answered it correctly. Now, these two questions are pending. Moving ahead to the second last question of the quiz. The time is up, and the correct answer to this question was pod failing due to lack of resources go into evicted status. Around 43% of you answered it correctly. You can refer to the explanation seen on the screen. All right, so just one question is remaining now. All the best. And the 10th question will soon be on your screens. The time is up, and you can see the correct answer and explanation. You can around 38% of you answered it correctly. All right, so with this, we have come to an end with today's quiz and today's meetup. And let me tell you that the top five of today's quiz, the top five who top the leaderboard on this quiz leaderboard, will get vouchers over 200 INR, and they will be contacted via email in few days. And with this, we will end this quiz and the meetup. If you are looking for more winning opportunities, make sure you check out the Devtron blogathon contest. The link has been pasted in this live chat and also pinned. And if you want to keep up with all the community activities that we do, you can follow us on Twitter and LinkedIn to stay updated. And congratulations to all the winners. And thank you for joining today's meetup and quiz. Have a great day ahead.